Jetzt.
Jetzt, genau. So, es geht los. Mach die Fenster zu. Hello. Welcome to our talk about the software. It's awesome. It's awesome. It's made in Germany. It's about deepfakes. And we want to show you how so awesome, how neural networks will change our world.
Yes, hello. Thank you for the introduction, Mr. Trump. I'm just going to start the screen share now. Let us know if you cannot hear us for whatever reason. And you should be able to see our screens now. Yes, welcome to our talk, Deepfakes 2.0, how neural networks will change our world. Yeah, we shall just jump in. So with a quick round of introduction, my name is Jonas. I'm the guy that's standing in front of the camera, and I work at TNG Technology Consulting. I'm a software consultant, and I play around with different projects with innovative technologies such as the deepfake one. And with me today, I have Dr. Martin Förtsch.
Hello, ladies and gentlemen. So I want to introduce myself. So my name is Martin Förtsch. I've studied computer science and applied sciences, and I'm working for TNG, which is a consulting company, for 15 years right now. And let's go over to Thomas.
So hello everyone, my name is Thomas Endres. I studied computer sciences as well, and after my studies I joined TNG. And with TNG we are working on innovative showcases actually, and there have been quite a lot over the years. Some of them you will also see today, and the most recent one, or actually already the latest one, is deepfakes, and this we will show you today. But before we start, Martin wants to show you a little bit about a certain president of the United States.
Yeah, so let's go to this guy here. Yeah, you probably know him. This is the former president of the United States, Barack Obama. And he once said something like, did you hear that? Let's repeat that. I'm not okay with this. But the question is, did he really say this? So when speaking about videos, we should remember also when it comes to online news articles, just don't read only the headline. Also have a look to the whole video. So let's do that. Yeah, this is a dangerous time. So the topic about deepfakes is a very controversial topic. And Carl Bergstrom of the University of Washington, he once said, when a new technology like this comes along, the most dangerous period is when the technology is out there, but the public isn't aware of it. That's when it can be used most effectively. So we want to introduce you into the topic of deepfakes. We are showing the original implementation and how it works with Deepfakes Lab. Then we want to introduce you into real-time deepfakes, because we in the innovation team of TNG Technology Consulting, we were able to make it real-time. Then we want to talk about fields of application, and last but not least, a conclusion. So whenever it comes to deepfakes, this Obama video is shown to the audience. And let's have a nearer look on that. we want to make a differentiation between different fake types. So we call this the Obama lip sync. And the question is, how does it work? At first, we have some audio information of a voice double. And this audio waveform goes into a recurrent neural network, which identifies the mouth position. So you can do some kind of mouth tracking based on audio information. And then you just copy and paste with some retiming the best fitting mouth parts from the source video to another time code. And as this is not created by a deep neural network, the final output, the fake output, this is not approved as a real deepfake. So Jonas, we want to have a look to another kind of fake.
Yes, exactly. So what you can see here right now, that is the traditional face swap. And you might know it from apps like Masquerade or Snapchat or Instagram. And what is basically happening here while Martin and I had a beautiful day in the office back in the day is we have some sort of face detector that kind of detects where our faces are at, and it crops the area of the face, and what happens after that is basically a glorified copy and paste. So it takes my face, inserts it into Martin's head, and takes his face, inserts it into mine. And you can see the illusion breaks quite easily once you start doing different facial expressions, sticking your tongue out, and just doesn't seem to line up with what the head itself is doing. And the worst part about it, the faces, they are just copy and pasted. They're not coming from any kind of neural network or such. And for this reason, there's no deep learning involved, and that's why we do not approve this as a deep fake. So let's have another look at another approach then, and this is the face-to-face real-time reenactment approach that comes from a couple of guys at the TU Munich just around the corner right there. And what happens here, you can see we have the source actor and we have a target actor. And what we do is we take the facial expressions of the source actor and apply them to the video, to the head of the target actor. And this works by having a parametric face model that is fitted to the videos of both the source and target actors. And that parametric face model encapsulates both facial expressions as well as shape and the color of the face. And this then allows you to split up the parametric face models for facial expressions and appearance and to merge them together, as you can see in the slides right now. The big issue here for us is that this is all cool, but that's all done with classic optimization techniques. There's no machine learning involved here. There's no neural networks, no deep learning. So we cannot really say that this is a deepfake. So what is a deepfake then, Martin?
Yeah, so for all those examples here, there are papers existing. And so we just did some research, and it was really hard to find papers regarding the real deepfakes. So the only thing we found was a forum entry in Reddit. And yeah, what did we see there? At least some people tried to show some famous actresses in some kind of a movie genre where they don't belong to normally. So we did a lot of research, watching a lot of videos with bleeding eyes, and then we just found something we actually can show you. And let's have a look to this one. So here you can see Amy Adams, and she played, she was an actress in the movie Superman. Yeah, right, Superman. And on the left side, you can see the original footage, and on the right side, is still Amy Adams. She looks a bit different. Let's zoom in. So what you actually can see here is a Nicolas Cage-ified version of Amy Adams. And the interesting thing is that this was created with Deep Face Lab. So a guy named Deepfaker was developing this kind of stuff. And what you can see here, actually, the Cage-ified version of Amy Adams, is created by a deep neural network, which was trained for several hours on Amy Adams' face and on Nicolas Cage's face. And as this is created via a deep neural network, this is definitely approved as a deepfake. So now we want to introduce you how such training of a neural network of an autoencoder works. So let's start with a motivational speech of Shia LaBeouf. He's also a very famous actor, played in Transformers. And let's have a look to the motivational speech right now. So let's have a look to Shia LaBeouf's face. Is this still Shia LaBeouf? This is the question. Of course not. It's a Martinified version. So it's my face on Shia LaBeouf's head. And we created that with Deep Face Lab. So you actually can download this piece of code, roughly 1.3 gigabytes of software you have to download on GitHub. And then with a powerful computer, you are probably able to generate your own deepfake videos within several hours. In this case, we needed about 5 to 6 hours on a machine with a NVIDIA 1080 Ti graphic card, and then we created this video. And now we want to introduce you in the different steps. Thomas, what do we need to place my face on Shia LaBeouf's head?
Yes, of course we need, first of all, the video from Shia LaBeouf himself, but also we also need some other video, and this is video material from Martin. And as you can see, Martin is fooling around a little bit in this video. So he is looking to the left, to the right. He is performing different facial expressions. So, for example, he is laughing, he's crying. So we need basically every emotion that Shia LaBeouf is showing in his video also, so that the neural network can really learn to identify the same expressions in both videos. And with that, we also need the video from Shia LaBeouf, and we can take this as a given. And using these two videos, we can then do some extractions. So first of all, we need to grab each and every video frame from those two videos. Then we do a face recognition on each of these frames. And then we can do a face extraction. So we just cut out the part that is really concerned with the face. And then we also do some kind of alignment so that the face is always looking centrally into the camera, that the face is not somehow tilted to the left or to the right. And with all these modifications, we are then ready to put this into our data sets that we can use for deep learning. So how does all this face recognition, face extraction, and all these other details work? Actually, we just need one neural network for this, and this is the so-called FaceNet. So FaceNet, most of you have probably already used it, even if you are not aware of it, because FaceNet is part of Windows Hello. So it is used for identifying you as a person when you log in with your face. And what FaceNet basically does is it is a robust neural network with which you can detect face landmarks. So there are, I think it's 72 landmark points that you can detect with FaceNet within your face. And there is the contour of your face, there's your mouth, your nose, but also your eyes and your eyebrows. And all these features are detected. And with these features, you can do a little bit more. So you can, for example, just grab the part that is your face. So this would be a classical face detection. This is the blue box. It's a bit too small, but it's always a bit too small because it's just half of the face. And then we also have this red box, which is also the alignment of the contour or of the whole face. So with this alignment, we can then rectify the video. And using this information, you can now see within the Shia LaBeouf video how this all plays together. So here you can see the face contours as well as the face rectangles, and you can see that it works pretty well. So it's pretty precise and it detects the face accurately in most situations. In some situations, there a hand is also detected as a face, but this is rather rare. So it's a quite good neural network. The problem with it is, however, that it's pretty slow. So even on fast hardware, you can run it with probably 2 to 3 frames per second, but not in real time. So you cannot do this with 30 frames per second. And once you've got that and you've done all these steps, you can now see the results. So what you can see here is that the person is always looking directly into the camera, the face is centered, and the nose is normally always in the middle. And it's also not tilted to any side. And with these images, we can now train our neural network to really do deepfakes. And Jonas will tell us a little bit more about how this works.
Yes, exactly. Talking about training, so what is actually training? We have the brain of the deepfake, a neural network, and in this case, it is an autoencoder. And as you can see here in the slides, an autoencoder consists of two parts. It's an encoder and a decoder. What basically happens is the encoder takes an image of a face and breaks it down to, well, a low-dimensional so-called latent space representation. And that latent space representation, that contains all the information about the face, about the facial expressions, which direction, face looking at the angle of the head, lighting conditions, etc. And what the decoder then does, it takes this latent space representation and reconstructs the original image of the face from that. So let's just have a look at how this would work. For the deepfake, we now have two faces, so we have two autoencoders, and the clue here being is that both of them share one encoder. So we can do the following. We can take the face of Shia LaBeouf, we can feed it through the encoder, it breaks it down into a latent space representation, and then feed that through the Shia LaBeouf decoder once again, and then we get the same face, which is actually quite boring. So let's have a look at how the deepfake works exactly. So we again take the face of Shia LaBeouf, feed it through the encoder, but this time around we feed it through the decoder of Martin. And so finally, ultimately, we end up with something that looks quite spooky because it looks like Martin, but with the facial expressions of Shia LaBeouf. And this is how the deepfake do. Anyways, let's just have a look at how the training looks like in Deepface Lab. You can see like a screenshot of from Nicolas Cage to Donald Trump. And you can see we've been training for around 60,000 iterations, so we're quite far into the training. And in the first column here, you can see the input faces for Nicolas Cage. So those are the real faces extracted from the video. And then in the second column, you can see how the autoencoder has reproduced those images from the latent space that it derived. And then in the second and third column, you can see the same thing for Donald Trump. So first the input and then the output. And you can see in both cases, we're pretty close to our inputs. So we're pretty good on there already. And the very interesting step is the last column here, and that's basically feeding the Donald Trump latent spaces into the Nicolas Cage decoder. And then we end up with the face of Nicolas Cage, but with the facial expressions of Donald Trump, and that's what the deepfake is. So if we're having a look at what is going on under the hood, basically we start with completely untrained neural networks that initialized from scratch. And we have the encoder and we have the decoder, and we have our images of Martin. And what we're going to do is we're going to feed the images of Martin into the encoder through Martin's decoder, and we're going to make sure that whatever comes out, we compute the difference of that to our input, create a loss function with that, and train the network with that. And that will make sure that eventually the outputs will be pretty similar to the inputs. And while we're doing that, we're doing the same thing for Shia LaBeouf as well. So we're training the encoder with two faces at the same time. And only because we do this, the encoder is able to understand both of those faces and break them down into the same latent space representation, which allows us to then just swap the decoders. So we're just going to have a look at the time lapse of how the training would look. And you can see the neural network starts from a gray output and slowly begins to, etch out the contours of the faces. You can see we have like the beard of Shia LaBeouf and the face of Martin. And you can see right now the faces are kind of starting to wiggle around a bit. And that is because the neural network is just now learning how to detect and process rotations. And if we skip a couple of thousand iterations ahead, you can now see that every now and then Shia LaBeouf is kind of starting to frown, Martin is starting to show his teeth, and what is happening here is that the neural network is starting to learn the facial expressions as well. So the decoder is learning how to pull them out of the image, the encoder is learning that, and the decoder is learning how to reconstruct the facial expressions from the latent space. And we're going to skip a couple of thousand iterations ahead until the final step of training. And you can see that right here. And you can see the reproductions on both ends are pretty good already. And the deepfake from Shia LaBeouf to Martin is pretty good as well. But on the deepfake from Martin to Shia LaBeouf, you can see down here we have some weird green artifacts in the face. So we're not quite there yet. There's still a little bit of training that we have to do. Anyways, so now we're done with training. Now we have our beautiful neural network that does the deepfake for us. How do we now actually run the deepfake? How does the inference look like, Martin?
Yeah. So let's have a look to the inference. So the inference workflow works as follows. At first, we start with our input video frame, which is from the original source video. Then we do our FaceNet face identification. And this information goes into the trained autoencoder. And the autoencoder gives us back two very important information. So one is the suggested most fitting, best fitting face regarding the input video frame. And the second information is a mask. And using the mask with the suggested face, we can merge our faked final video frame, which is, as you can see, a Martinified version of Shia LaBeouf. So everything you just learned right now about Deep Face Lab is typical post-processing, post-training. So at first you need your source video, another video of the person you want to fake into the source video, and several hours of training, and so on and so on. And now we want to speak about the motivation to realize something like Deepfakes 2.0. What was our motivation? What do we want to? What was our goal? At first, we wanted to make our implementation work with any face. The idea is that you are just standing in front of a camera, and so that the neural network has not to be trained on your face, so it should just work. Another feature is that not only the face, also the whole head should get replaced. This was another goal. Everything should work with ludicrous speed, so in real time. And last but not least, we wanted to do that with clean code. And now we have a look to this Deep Face Lab inference workflow, and we want to show you which parts we substituted with our own development. And now Thomas comes in place, and he wants to talk about the face detection with OpenCV in this case. Thomas.
Yes, so when it comes to face detection, we had a look at different implementations, and the one we ended with was actually a face detection done in OpenCV. So OpenCV is a computer vision library, which normally does not support neural networks, but there is an experimental branch which you can use to, for example, load TensorFlow models, and then it will be integrated into the normal OpenCV workflow. And this will work pretty well, but it will work on the CPU. For us, this was no problem in this case, because our GPU is occupied with other neural networks. So that's pretty good to do it on the CPU in this case. And the code is also pretty easy. So you can download a TensorFlow model and a config file, actually from the OpenCV homepage. And then with these files, you can then load the neural network. And this is what the code looks like. So in the first line, we just read the neural network from the TensorFlow files that we can download. Then we just create an image, a blob from the image that we get. In the next line, we just set the input of the neural network to this blob that we just had. And in the last line, we can then do a fast forward an inference within the neural network. And with this, we get our face candidates, which we can then use for further processing. So now let's have a look at a short demo. So as you can see right now, Martin is also here, and Jonas will be here as well. And you can see that the face detection works pretty well, even if I look sideways, or even if I have my hands in front of my head. So even in these extreme situations, the face detection works pretty well, and it works in real time. So this is what we need for this, for our purposes. So then the next thing that we need to do is a so-called face segmentation. So before we had this FaceNet approach. With the FaceNet approach, as you might remember, we had these contours, and these contours could be used to determine the inner workings of our head. Now with Deepfakes 2.0, we really want to have the whole head and use that as an input. So we also need every pixel that belongs to the head, and therefore we can do a so-called segmentation. And our segmentation works the following way. So first of all, we take a fast neural network, a so-called mobile net. Mobile net is normally a network which is used for classification, so it can tell us whether that's a car or a cat or a dog or something like that. But if we just cut away the last layers of the neural network, we can use this net and put another net behind that. Oh, sorry about that. And put another net behind this mobile net neural network. And this is a so-called UNet. And UNet is a neural network which we can use for segmentation. So given an input image, it returns an output image where each of the different segments has a different color. In our case, the head should be blue. And if we just take a pre-trained neural network for MobileNet, so MobileNet is a pre-trained network, and we take an untrained UNet, we don't have to learn all the intrinsics ourselves, but we just have to train it for the specifics of our application. So this is an approach which you could call transfer learning in this case. And with that, we take a data set, a so-called celebrity data set, and this has 30,000 faces in it. And there was some guy who was really segmenting all these faces by hand. So he just sat in front of the pictures, took the pictures, said, okay, this is the head, this is the hair, this is the nose, this is the mouth, and so on and so on. And this was done for 30,000 pictures in total. And we can just use this information to train our neural network to do some face segmentation. So without further ado, let's also jump into a demo here. So now you can see, the demo, and you can see that our heads have turned blue. So we are kind of Smurfs here. And if I turn my head to the side, you can already see a bit of the shortcomings of our approach. So it works pretty well, but it doesn't work perfect in all situations. And this is due to the fact that celebrities don't like to look into the camera sideways. So whenever we tilt a little bit to the side, it might be that the that the segmentation is not that correct anymore. But if I look centrally into the camera, it works pretty well. And what we also saw, these are all networks which are optimized for real-time usage. So we can use them in real time and get our feedback with almost 30 frames per second. So this is fast enough for us. The next step will be to really get rid of all the heads that we have right now. And Martin can tell us a little bit about mask blending.
Yeah, so as you already learned about Deep Face Lab, the autoencoder gives us back the mask, and there is some mask blending involved. And now let's have a look what happens if we want to place Thomas' head on my head. Here you can see a little animation, and you probably see that there is a little problem. Let's stop that here, let's pause it, the animation, and then you can see there is some kind of overlapping which doesn't look good. So just imagine placing Thomas' head on my head, and then you will have some artifacts of my head. This doesn't look really good. So we did some research what we can do here, and we just stumbled upon so-called image inpainting. And image inpainting is normally used to, for example, restore old photographs. And in this example, you have this original video, image, and there are some scratches on. And with image inpainting, you can just fill those scratches with some pixels. And now we want to have a look to the source code, and you can see it's extremely complicated to do inpainting. Of course, it's not. So we just call a function called inpaint, and you have to provide the input image and then the full image mask, which is in this example, of course, the fragmented head. And then you can specify the inpainting method. In this case, it's Tilia. And that's it. And now we want to show you how this looks like in our real-time demo. So I'm now in front of the webcam, and you probably see that I'm not existing anymore. So the head gets erased out of the image. And let's have a look how it works. So when I go in the direction of the fragmented face, you can see that it looks like that the pixels are going into the center of my original head section. And so this is how Telea just works. That's it. And still everything in real time, no problem. And it doesn't need to look perfect because another head gets placed on my head. So no need to have a perfect inpainting here. So now let's have a look to the autoencoder. Jonas.
Yes, the autoencoder. So we've basically talked about everything in the pipeline that has not to do with the deep learning part in the deepfakes. So let's have a look at what we did to the autoencoder. So the big issue that we had is we wanted the deepfakes to work for any face, and we wanted to have it work for a lot of faces. And so, I mean, the first thing that we changed was to feed the entire head into the autoencoder now. The second thing that we did is, well, we went from 2 decoders to n decoders. So basically, if we wanted to train 17 faces at once, we now have 17 decoders. And that's going to allow us to train a Martin, a Charles Above, a very interesting German internet person, and basically all the faces that we wanted to train. And this has the nice side effect that because the encoder has now seen so many different faces, it really learns to break down basically any face. It learns how faces generally look like and how to break them down into one latent space. So this allows us then to just take any person and step in front of the camera and then have a deepfake of us. And the only issue here is that with all the changes that we made, with feeding the entire face and with not aligning the face anymore as we did previously, and with having so many faces at the same time, the job just got a little bit too tricky for our poor little autoencoder. We ended up with something like this. So yeah, we have a Martin basically with an eye on his forehead, and then we have like a Picasso painting, and this is just like some random faces that we got during training. Here we have Trump with an eye on his forehead. I don't even know what that is. This is, I don't know, man, bear, pig. This is watermelon head, Obama. And yeah, we kind of realized that the objective was just too hard for the poor little autoencoder on its own. And for that reason, we decided to reinforce it and to give it some help in form of GAN training. And what exactly is GAN training, Martin?
Yeah, the so-called GAN training is generative adversarial network. And how does it work? Yeah, it's a fight between a generator and a discriminator. So the generator in this case is our autoencoder, which generates artificial faces. But from time to time, it just provides a real face to the discriminator. And the discriminator has to point out which one is the faked, the artificial face, and which one is the real. And this is a fight between the generator and discriminator. We want to show you in an offline roleplay game. So Thomas, please help us, and you are the referee, and you will you will make the game with us.
Okay, so let's do this. So Martin,
okay, yeah,
you will be the generator.
I'm the generator. Okay.
Jonas,
Yes.
you will be the discriminator.
Okay, cool.
Okay, so what? So first of all, I think I need Martin, and Martin,
Yes.
you will get a picture of a face.
I will get a picture of a face. Okay.
So do you know what a face is?
No, I've never seen a face.
Okay. Okay, you will figure it out.
Okay.
And you will have to paint this face anew.
Okay.
Just do it the same way as the picture that you have already. Okay. So and then Jonas will have to tell us whether this is a real. So he will also get two faces, and he will tell us which face is the real one and which one is your creation.
Okay.
Okay. So first round. Close your eyes. Okay.
Okay.
So now there's a picture.
Ah, okay. Yeah, I see. This is Shia LaBeouf. And I shall now paint it. I shall recreate this face.
Please recreate.
This is from the original input video.
Yeah.
Oh. So I'm newly initialized deep neural network. All my weights and biases, there are just 0. And I don't know where to start. So, I would typically start with some kind of noise. So I'm finished with the recreation of Shia LaBeouf's face. So please.
All right.
You can provide that to the discriminator.
So discriminator, please open your eyes again.
Yes.
And now you can have a look at these two pictures. So
Okay.
One of them was created by Martin, by the generator, and one of them is a real picture. So can you tell us which is which?
Well, that's a tough one because I've literally never seen anything, and we just lost the camera there. Stand by.
Oh.
I would suspect, and we're back. I would suspect that the one with, I don't know. I'll just randomly pick the left one.
Okay, let's see if you are right.
Oh, damn.
So what did you learn from this experience?
Well, it seems like the fake one just is random noise, and the real one has like something like connected lines.
Okay, but so generator, did you learn something from this as well?
Yes.
Okay.
Yeah.
So discriminator, please close your eyes again. Oh. And generator, there's another round and another face for you.
Okay, so my weights and biases are not uninitialized or on the default values. So I learned something based on coast functions and stuff. So I try to make. So let's have a look. Okay. Connected lines was something like that, and yeah, I think this is quite good. So please.
Okay, so please, discriminator,
Yes.
you can have a look again.
Well, honestly, this is quite tough again. It's so much better now. But I also kind of remember that the real one had like color in it last time around, so I think I'm gonna go for the left one.
And I think you are right in this case. So now we could do this for thousands of iterations, but we actually won't. So this is the last one. This is the point where the discriminator cannot tell us anymore whether which one is the real one, and the losses are so small that we can really stop here. And with these iterations, we are now finished. And Jonas will tell us a little bit more of how this works in theory and not in practice.
Yeah, as you can see, in the end, the faces look exactly the same. But what we basically played here is we have real faces, feed those into the discriminator during training time, train it to classify those as real, and then we have the generator, which is our autoencoder that generates fake faces, and we then discriminate against those, and train the discriminator to classify them as fake, and train the generator to generate images that are classified as real. And that's basically how a GAN works. So anyways, we are just going to stop sharing our slides now and put back on our beautiful faces once again to show you what exactly we can now achieve with all this beautiful GAN training. So we have a nice little Donald Trump here. We also have like some people from German TV that we're technically probably not allowed to show on this conference. Shout out to the German people. We have an older version of me, so a younger version actually, that just works for one face at the moment. Who else do we have? Yeah, you can see you can also go bold if you want to do that, and you can see it also. It just works. It's magic. You can see I am. Yeah, I do have glasses. I do have facial expressions. You can see I'm talking, I'm smiling, I'm blinking, all of those things. Let's see, who else do we have? Oh yes, you might know this person. This is the interesting thing is you can actually also do just a gender swap if you wanted to. And the interesting thing is, since the neural network learns from the data that it has, if it doesn't have something in the data, it's not able to reproduce it. For example, Angela Merkel cannot smile. It just looks really, really creepy. Anyways, let's just bring back the slides, and then we shall have a look at what else you can actually do with stuff like this.
So let's move on. So yeah, fields of application is a question. So I ask the audience in this case. So what is which video snippet is generated by CGI and which one is generated by the deepfake stuff? 3, 2, 1, and we solve the question. So the upper part is generated by CGI and the bottom part via deepfake. So the CGI generated fake of Princess Leia costs hundreds of thousands of US. If you have a look to the deepfake implementation, this is just consuming power, electricity, and of course powerful graphic cards, and is only a very, very small part of money, amount of money. Of course, this kind of stuff will get used to create fake news, but you can use those giants to identify them. But it's a cat and mouse game, so which is probably a problem. But a Jan can identify if something is fake or real, if it's trained well enough. Of course, deep fakes are a legal gray area, so go for sure that you have the permission of the persons you want to fake, and you probably should also check if you are allowed to upload that to any portals. Yeah, now let's have a look to the state-of-the-art living portraits, Thomas, please.
Yeah, when it comes to deepfakes, there's also another technique that we introduced a few years ago, or where we had a talk about, and this is the so-called style transfer, where you can apply the style of a painting to the real world. And if you combine these techniques, so deepfakes and style transfer, you get something like this. So you can bring pictures to life, or you can bring paintings to life, and this is called living portraits. So it's an interesting technique. If you want to know a little bit more about style transfer in general, you can have a look at our talk. Just photograph this QR code and then you will be redirected to the talk itself. So now we are finished, and thank you very much for listening. And if you have any questions left, then feel free to ask them. We will also be available in the backstage later on. Let's have a look at Q&A. No questions yet.
Yeah, so if there's any questions, just feel free to spam them in the chat or in the Q&A section. If not, then we thank you for your attention. We hope you had a good time. We definitely did.
Thank you very much.
Let's see, who else do we got?
Yeah, we can just skip through a few faces. Let's just put on the glasses.
Let's just make.
And we can also make funny faces and bubble heads. And bubble heads. It's too much. It's just too much. Okay. So thanks again. And then I think we'll end the session.
Yeah. Check out our socials. Thank you for listening. See you next time.
Bye-bye.
Peace. 10 seconds. Do something funny. Yes. There we go.